Alright, so here it says student is going to guess on a true-false test. Okay, there's 50 questions. And it says passing is 35 or more. Is if you get 35 or more. And it says test the claim that a student knows more than half of the answers and is not just guessing. Assume the student gets 35 answers correct. So what we observe is 35 out of 50 correct. 50 questions are correct. And we want to see, test if the student actually knows more than just complete guessing. And it tells us that the null hypothesis is that the proportion that the student got right could just be from complete guessing versus the student actually knows more than complete guessing. And it says in step 2 it checks the conditions and it says conditions are met. Okay, so what we observed is p hat, and that's 35 out of 50 questions correct. So our p hat is 70%. And is this different enough for us to conclude or to reject the null hypothesis? Okay, so our test statistic, as always, is what we observed minus what we expect in our null hypothesis divided by our standard error. So what we observed is 0.70. What our null hypothesis expects is 0.50, and we're going to divide by our standard error. So what is our standard error? Our standard error, we take the square root of p from our null hypothesis, 0.5, times 1 minus p, which is going to be also 0.50, divided by our n. Our n is 50 questions. So in this case, I got 0.5 times 0.5 divided by 50, and I take the square root of that, and I get my standard error to be 0.0707. So I'm going to plug that in right here. So on top I have 0.20 divided by 0.0707. And I get a test statistic of 2.83. So my z is equal to 2.83. So according to my picture, I would be centered at 0, and I'm drawing a cutoff line at 2.83. And because my alternative hypothesis is p is greater than 0.5, I only shade in the greater than direction, and the area here, this is going to be my p-value. So if I look up 2.83 in my normal table, 2.83 gives me the area to the left is 0.9977. So this area over here is 0.9977. So the area over here is going to be 1 minus 0.9977, which is equal to 0.0023. So my p-value is 0.0023. Okay. If I use alpha as 5% or alpha 1%, okay, whatever I want to use, if my alpha is 5%, whatever my p-value is less than alpha, which means the probability that I observe 35 out of 50 questions right, if the student's just guessing, is about 2 in 1,000. 2 in 1,000 students will manage to just correctly guess 35 of the questions. That seems really small. So I reject the idea that the student's just randomly guessing, and I conclude that the student actually knows some of the answers. Okay, so I reject H0, conclude that the proportion that the student gets right, student knows, is over 0.50.